Hey YouTube, today I wanted to create a video about how to create trunks between switches. So in the previous video we created different VLANs on a switch. But what happens if we need more ports to connect devices to? Well, we need to add another switch. So everything we did last time we need to do again for this next switch. Create the VLANs, assign them to ports. However, if we want the devices on the two switches to talk between themselves, then a connection between the switches has to be made. So if one were to simply connect a port on one switch and plug it into the other switch, will that work? Well, yes and no. If the ports are both on the same VLAN, that the devices will be able to talk to each other. So if the port is, say, VLAN 10, and then on the other switch you plug it in on a port that's VLAN 10, then devices on switch 1 on VLAN 10 will be able to talk to the devices on switch 2 on VLAN 10. But how do we get VLAN 10 to talk to VLAN 10 and VLAN 20 to talk to VLAN 20? Do we need two links? One on VLAN 10, one on VLAN 20? Well, that would work. You could have an interconnect on both VLANs between the switches. However, that's not going to scale very well. If we're going to have 10 VLANs on the two switches, then we'd have to use 10 ports on those switches. There's a much better way, and we're going to discuss that now. What we need is a trunk link. So a trunk link allows multiple VLANs to pass through the interface. So the standard method of creating a trunk is called using an 802.1q trunk. Now this is a standard-based method, inserts a 4-byte tag in the frame as it passes between the switches. This tag has a field that includes the VLAN identifier. So the VLAN identifier field is 8 bits, so it allows up to 4096 VLANs across the interface. Alright, so how do we go about configuring this? Well, on a Cisco switch, we connect a port on each switch. Again, we must go into configuration mode, which I'm in already. You get into this mode by typing config T. And as you can see, there's a shorter way. Last time I put configure terminal. This time you can actually just do like conf T, C-O-N-F T. So I'll show you. So instead of typing configure terminal, I could actually just type conf T. Just a little bit of a time saver. And you can also use the question mark to get some more options. Oh, this helps if I'm out of the proper mode. It shows the other options for configure. And the tab finishes the current command. So it's another little time saver. Now, this doesn't necessarily always work. There's chances where if you want to do, let's say, show interface statistics, and you type show int stat, it says incomplete command. And the issue is there's two different options for that. So you could do stats or status. So sometimes if that happens, you can just have to add another key or character to it. Okay, so let's actually start getting to the configuration. So once we're in the configuration mode, we need to go to the interface that will be used as the trunk. So in my case, I'm going to be using interface Ethernet 3.3. So I'm going to go to that interface, and I'm now in that sub-interface. I need to tell the port that it's going to be a trunk. So I'm going to tell it what method to use for trunking, which I mentioned earlier was .1q. So I'm going to tell it switch port trunk encapsulation .1q. Alright, so now we've told it what protocol to use. And now, in the previous part on the VLANs, we had to tell the port mode it was going to be access port. Now we want to tell it it's going to be a trunk port. And the command for this is switch port mode trunk. So that's it. The port is now a trunk. But as you can see, it bounces from down to up. But we also have to do that now on the other side. So I'm going to go on the other switch and do trunk encapsulation .1q. And then switch port mode trunk. Alright, so that's it. So now computers on VLAN 10 can talk to computers on VLAN 10 on the other switch, and computers on VLAN 20 can talk to computers on VLAN 20 on the other switch. So one thing we can do to make sure this is more secure is to limit the VLANs that can go across the trunk link. By default, all VLANs would be allowed. So to minimize that, we can type switch port trunk allowed VLAN. I'm going to say 10 and 20. So I'm now also going to do that on the other switch. Now there is a catch. If you need to add a port, you have to actually use the add command as well. So if I just typed 11, it actually overwrites the previous two. You have to type add 11. So now if I show the configuration on this port, you see it has 10, 11, and 12. And if I want to remove a port, I have to use the remove. And we'll show that command again. And now it's back to 10 and 20. Okay. And then this will now limit only those two VLANs across. So one other thing we could do is we can change the native VLAN used between these two switches. By default, the native VLAN is VLAN 1. So we can switch that to, say, VLAN 10. Trunk native VLAN. I'm sorry, we'll do VLAN 5. I'm not going to use the same as my data VLAN. Native VLAN 5. And then what this command does is when it sees traffic from VLAN 5, it's not going to tag it as it goes out. Or if traffic comes in, it tags it as 5. It's like I said, by default it's VLAN 1. It's a security practice to possibly change this to help stop VLAN hopping. But alright, so now once this has been completed on both of our switches, we can then do some testing to verify that this is in fact working and as a trunk. So one of the best commands you can use is the show interface trunk command. And it shows my trunk is Ethernet 3.3. It's turned on, and we're doing 802.1q trunking, and the native VLAN is 5, and the allowed VLAN is 10 and 20. A command that is used for access ports is also useful for trunks as well, is the show interface Ethernet 3.3 switch port. Because what this shows us now is that it's administratively set as trunk, so it's operating in trunk mode. The encapsulation is .1q, and the trunks allowed are 10 and 20, and that again encapsulation is .1q. Oh, this is private VLAN. That's a little different. So another command that's pretty helpful to use to troubleshoot or just to see all of your interfaces and see which ones are actually a trunk is the show interface status command. And you can see immediately this one is set as a trunk. So I just wanted to show I have PC1, PC2 on VLAN 10, PC3 on VLAN 20 on switch 1, PC4 on VLAN 10 on switch 2, and PC5 is on VLAN 20 on switch 2. So we can actually test the ping. We'll show the IP. I think I might have to do a DHCP command on a couple of these. This should be working, but I'm just going to manually set the IP forgot how they liked it written out in CIDR notation, so I'll write it out in CIDR. I thought it was. Oh, IP address. Oh, I have to put the gateway as well? I'll try that. Learning together. Oh, I don't have to do the address part. That's just a command that Cisco requires. So we'll do this way. There we go. So in here I'll do the same. I'll do oh, he was able to get an IP. So he's now able to ping switch 1, because that's this computer's IP. And then he is 10.3, so we'll try pinging him as well. And he's able to ping him. Let's see if he is able to ping switch 1 as well on the other VLAN. So here we can see that PCs on one switch can talk to the other switch on both VLAN 10 and 20 using this trunk link. So that's going to wrap up this video on trunking in a Cisco IOS. In this next video, we'll begin looking at spanning tree and why that is needed on switches. Thanks.